validity of truth table techniques. So how do you go about finding out validity of truth table techniques? I am representing a truth table by P dot T. So given a set of premises H1, H2, Hn, let us assume given a set of premises, say H1, H2, etc., Hn, and you are given also a conclusion along with it, and given a conclusion C, if the rows in which all HIs are true, if the rows in which all the HIs are true, the rows in which all the HIs are true has conclusion also true, has our C also to be true, then we say that it is a valid conclusion. Alternately, there is one more choice. Okay, this is one choice, and then alternately, there is a second choice. So, what is the second choice? If every row of C, if every row of C, so we are going every row of C having false has at least every row of C having false has at least one HI has at least one HI to be false, then we say that it is a valid conclusion. So keeping these two things in mind, we will now check whether the following rules given to us are valid conclusions or not. So how do we go about these rules? So let us take a very simple sum. Show that the following rule is valid. So what should I show? I must show that if P, then P or Q is valid. So how am I going to show that this is going to be valid? I can use either of the two rules which I have stated in the first slide. So how do we go about this? The first thing what we have to do is we first have to frame the truth table. Now how am I going to do the truth table? That is as usual. We have P, we have Q, and then we have P or Q. So there are two variables. So there will be four columns or rather four rows. So there will be true, true, you will have a false, again you will have a false. Corresponding to this, you will have true, false, then you will have true, and then you will have false. P or Q is true if P is true or Q is true. So the first one gives true or true, true. The second one is true or false, which is again true. The third one is false or true, which is again true. The fourth one is false or false, which is false. Now come to our rule. We have to check whether it is valid or not. Now look, when P is true, what happens in lines 1 and 2? P is true in both the lines 1 and 2. And P or Q is also true in line 1. So we are safe. But what happens in the last line? We have P or Q to be false. See, look here. We are having P or Q to be false. In this case, our HI are also false. Therefore, it is a valid argument. Therefore, it is a valid argument. Okay, so this happens to be a valid argument. So now let us see one more example, a small illustration whereby you will be able to identify whether this is valid or not. Okay. Now consider the second problem. We have to determine whether C follows from H1 and H2. I have to check whether okay, check whether C follows. C is the conclusion. Check whether our C follows from the given hypothesis, that is our H1 and H2, from our H1 and H2. Now what is our H1 and H2? That will be given in the question for us. Our H1 colon, what is H1 colon? If P then Q. My H1 colon is if P then Q. Then my H2 colon, what is my H2 colon? My H2 colon is P. I have given the conclusion as Q. So I have to check whether C follows from my H1 and H2. So how do I check this for my H1 and H2? Now let us now consider what is our H2. Our H2 is nothing but P. Our C is Q. And then we want to find our H1 colon, that is if P then Q. Let us now construct a truth table. Our H2 colon, this value is going to be P for us. And then we have our conclusion, which is going to be our Q for us. We need P and Q to construct our H1, that is if P then Q. Now please consider this. Now what happens? You have true, false. Again you have true, false, false. And then under Q you will have true, false. Again you will have a true. And then you will have, if P then Q is false, only when P is true and Q is false. So corresponding to the second row, you will have a false. In all other places, you are just going to have true. Right? So this is what we have got. Now look into our conclusion. What happens? My conclusion C is false here in the second row, and it is also false in our fourth row. So what happens? When the conclusion is false, I also have one of the other entries to be false. If that is the case, it is enough. So now what happens? Here look at it. When the conclusion is false, I do have my entry H1 to be false here, because my if P then Q is nothing but our H1. See here, for this false, our H1 is false, and for this false, my H2 is false. Therefore, when the conclusion is false, either H1 or H2 is false. Therefore, by our rule 2, we can check that C follows from our H1 and H2. Therefore, I can very clearly say my C follows from H1 and H2. So, C is a valid conclusion. So, we have used both the rules and we have checked for validity of our formula. So, therefore, C is a valid conclusion. So, this is what we need to show. Right. Let us now look into one more problem. That way, we will go for a sum which may not be a valid conclusion. So, let us consider H1 colon if P then Q. So, given H1 colon if P then Q, and it is given H2 colon Q, C colon, it is given as P. Now I have to check whether it is valid or not. How to check? Construct the truth table as usual. So my C colon P, let's take this. I have my H2 colon value is Q. Then my third column, let me have H1 colon, that is if P then Q. Okay. So having this on hand, I need to construct the truth table first. So under P I will have true, I will have true, again I will have false, and then again I will have false. Under Q, this will be true, false, again it will be true, and again it will be false. Now I need to find out if P then Q. If P then Q is false, then P is true and Q is false. So only in the second line it is false. In all other cases, it is true. Now look for the conclusion. In the conclusion, we have to check where we are having false. So in the conclusion section, we have a false in the third position and we also have a false in the fourth row. Now corresponding to this third position, both the entries here are only true for us. It is not false. Whereas corresponding to the fourth row, our H2 is false, so we are true. In the third row, no HI is false. Therefore, what can I say? I should have at least one HI false when my conclusion is false. Here no HI is false. Therefore, my conclusion C is not valid. This is what happens. Therefore, my conclusion C is not a valid conclusion. So we have seen an example where we have applied the first rule, then we have seen an example where we have applied the second rule, and now we have seen the third example whereby the example is not giving us a valid conclusion. Okay, so this is all we have to learn under valid conclusion. Now let us see some extra problems, right? So how to check for certain other things like equivalence and implication. In the previous class, we had done around 4 to 5 sums where we were checking equivalence. So now let us try one or two more problems whereby we would like to check whether the given set of formulas are either a tautology or whether they are a contradiction and so on. Okay, so let us take some problem and let us start solving. Okay, using laws of logic. This is what we did now. That is the previous class, not now, just before what we did now. So we need to use the laws of logic and then show. So I am back to the previous session. So let us use the laws of logic. You remember we did something called as associative law, distributive law, commutative law, then idempotent law, and then after that what else we did? I think we did domination law, isn't it? Then De Morgan's law. I think we did around 10 laws. So using those laws of logic, we want to show P and Q, P and Q, then P or Q, then P or Q is a tautology. Tautology is represented by a capital P. Now I have not put brackets when I wrote this question. The reason is, let us now recollect what we mean by precedence laws. So under precedence laws, what do you know? Conjunction has the highest precedence over this conditional and what? Disjunction. So put a bracket for conjunction. Now we are left only with the conditional and disjunction part. Disjunction has precedence over conditional, therefore we put a bracket over here. Now we need to show that it is equivalent to a tautology. So how are we going to show that it is equal to a tautology? That is our main aim. So let us now start with the given expression. So I will have P and I'm going to have Q, then P, I'm having OR, I'm having Q. Okay, so this is equivalent to, I have to use one of the laws of logic. So what law I'm going to use here is equivalence law. If P then Q is equivalent to negation P or Q. Therefore, applying that law, I will have this as negation of, I will have P and Q, right? Then P or Q. Is this correct? I need negation of P or Q value. So that is nothing but negation of, in the place of P we have P and Q. In the place of Q we have P or Q. So negation P or I will have P or. Now what is this equivalent to? We can apply De Morgan's laws. Okay. So we can apply De Morgan's law. How to apply De Morgan's law in this place? For the first term, we know that negation of A and B is negation A or negation B. So apply De Morgan's law. See, you can apply De Morgan's law for this particular. So this will give me negation P or negation Q, negation P or negation Q, okay, or I will have P or, so I am applying De Morgan's laws. Okay, so applying De Morgan's laws, we get this value as negation of P and Q is negation P or negation Q or P or Q. Now what I do is I apply commutative law. Try to apply commutative law. Applying commutative law, this is negation Q or negation P or I will have P or this we are applying commutative law. Okay, so we are applying commutative law. Now rearrange these terms. What do you get? This is A or B or C. I take this whole thing as A. Okay, I will take this as B. I will take this as C. Right? So now I can apply again associative law. Apply associative law. What happens when you apply associative law at this stage? Yes, please. What will happen when you apply the associative law at this stage? This will be equivalent to, yes, what do we have here? We have negation P or negation Q. So you will have negation Q or negation P or what is the other term that we have? P. This is A or B or C portion and the C portion is Q or we are going to have is Q. So now look at this. This is going to be equivalent to, what is this going to be equivalent to? Negation Q. What do I have on hand? Or P or negation P is a tautology or Q. Now what is P or negation P is a tautology? What rule is this? This rule is known as negation law. So this is known as by negation law. By negation law, you are going to have. Now, what can I do? I know that negation Q, what do I know? I know negation Q or P is nothing but T, isn't it? Negation Q or T is nothing but T. What is that law? Negation Q or T is nothing but T. Yes, does anybody remember what law is that? Negation Q or T is T. Yes, please. Please recollect what law is it and then fill it up. I am leaving it for you. Negation Q or T will once again be a tautology. Then I will replace by Q, and I also know T or Q is once again a tautology. Hence, I have arrived at the conclusion that the given formula reduces to a tautology. Okay. I hope if you want to have a complete recap of the whole problem, we can come over here. So we need to show P and Q, then P or Q is a tautology. We start with if P and Q, then P or Q, and then I start applying equivalence law. So the first term becomes negation of P and Q or P or Q. Then I apply De Morgan's law to the first term and I write negation of P and Q as negation P or negation Q. So I end up with negation P or negation Q or P or Q. Then I start applying commutative law. For the first term, it reduces to negation Q or negation P. I retain the second term or P or Q. Now I club the first term negation Q or negation P as my small a, or I take P as my B, and or I take Q as my C. So my formula is A or B or C. What I'm going to do is I'm going to apply associative law. See, in this particular position, this is nothing but you are having A or you are having B or you are having C. But what I know that this is equivalent to I'm going to have A or B or so I keep applying this. So when I apply this, what happens? I move on to the next slide. In the next slide, it happens to be negation Q or negation P or P or Q. Now I know that negation P or P by negation law is tautology. Please substitute. So this implies negation Q or P or Q. But negation Q or P is once again tautology. See, this particular portion reduces to tautology. Therefore, this shrinks to P or Q, and we know that tautology or any other variable is a tautology. Therefore, we end up with P. Okay. So now moving on to the very next question. Let us try one more question. So without using truth table, let us try to show one more problem. Wait a minute, what shall we do? Yeah, we'll try to show if P then if Q then R all conditional statements. Okay, I need to show if P, then again I have to show if Q, then R, if P, then if Q, then R. What more can I show? If P, then if Q, then R implies, I have to show that implies if P then Q, then if P then R, if P then Q, then if P then, okay. So I want to show this using the laws. So how am I going to show this? So how to show this? Let us now consider, basically we want to consider only, what do you want to consider basically? One side and then proceed to the other. Now let us first take this entire element as A. Okay, I have to show A implies this whole element B. Okay, so what does this mean? This means if A then B is a tautology. A implies B means if A then B is a tautology. This is the basic formula that we have on hand. So let us try to establish this. So what I need to show, I have to show so what do I have to show? I have to show the whole thing with one more if then condition. So I need to show if P then if Q then R, then again I have to show if P then Q, then if P then R is a tautology. If I show that this is a tautology, it is enough. Okay, to show that this is a tautology. Now instead of rewriting the whole expression, let me write LHS equal to. So let me start. I will have my left hand side is equal to. Okay, so this is equivalent to. What I am going to do is repeatedly I am going to apply the rule. If P then Q is equivalent to, this is the rule we are going to apply throughout. If P then Q is equivalent to negation P or Q. This is what we are going to go on and on and on and on for this problem. So let me first take the first term. So I will consider this is going to be now negation P or inside the bracket I will have if Q then R. I will close the bracket, close it once again, and this whole term then I am going to hold this. If P then Q can easily be written as negation P or Q, put the bracket, then again simplify negation P or R, and then so now this is going to be equivalent to, this is what we need to check. So this is going to be equivalent to, I have negation P or again I have negation Q or R. So close the bracket. Then I need to use this portion once again. I will have negation of negation P or Q or I will have negation P or R. Okay, so this is what I am going to have. Now what we should do is we should try to take the terms separately and then see if we can do any clubbing here, so that we will be able to arrive at a much simpler term. So what can I do? Again simplify this. So this is equivalent to, I will have negation of, start, negation P, or I will have negation Q, or R. Again we will close the bracket, or this whole term repeats to be itself. So what I do is I try to take this negation inside. So this would be P and negation Q, or negation P, or R. Okay, just one step ahead we are moving. We have this. Now what we have to do is we have to consider this last term. Let us break this term and see if we can do anything with this term. We are having P and negation Q, or negation P or R. Here also we have negation P or R, that is there. So maybe we can rearrange and check if anything can be done with respect to these terms. So what we will do is let us first take the second term. So what happens in the second term is we are having P and negation Q in the second term. Okay. So in the second term, what are we having in the second term? We are having P and negation Q. We are having P and negation Q, or negation P or R, or we are having negation P or C. If we can reduce anything with this, it is of the form A or B or C. If you take this whole thing as A, and then you can take this as B, or so you are having it in the form A or B or C. So why don't we take it as A or B or C? What am I going to use? I am going to use my associative law. So this is going to be equivalent. Let me write it down. I will have P, I will have and negation Q, A or B. So or negation P, I will close the bracket, or I am going to have R. Now let us consider this. This is equivalent to, what is this equivalent to? Expand this. This is A and B or C. See, this is A and B or C. That means here what have I applied this? I have applied associative law. Now what I am going to apply is I am going to apply distributive law. So I plan to apply distributive law. So how to apply this distributive law here? A and B or C. How can I write this? C or A and C or B, isn't it? Or I can write it as A and C or B and C. So A and C. How can I rewrite this? This is what I have to check. The best thing is to rewrite this. So I will have this as negation P. Okay. A or B and C is A or B and A or C. So it is negation P or P and negation P or negation Q, isn't it? Or R. Okay. So this is what we will have. Now having got this, what more do we know? We know that negation P or P is nothing but true. So this is true, and you are having negation P or negation Q or R. Now what else do you know? True and this value, what will happen to true and something? true and some other value over here is this some other value. Therefore, this is now going to be equivalent to negation P or negation Q or R. So we have shift this particular expression to this particular expression. Now what do we actually want? Look at your slide number, we are in slide number 8. So why don't we look at the previous slide number 7. See, we have the second term. So the first term is negation P or negation Q or R, the whole negation. So apply associative law. So when I apply associative law, what happens? This becomes negation P and or I will have negation Q or R. Okay, so we will take this as equation number 1. Now what we do is we go back to slide number 7. So go to slide number 7 and we substitute in slide number 7. So what happens in slide 7? In slide number 7, that is, we are moving on to this slide. You can very well see I am going to substitute for the second term. So let me substitute for the second term in slide number 7. Okay. So now in slide number 7, I will have my left hand side as it is going to be equivalent to what? Negation of it's going to be equivalent to negation of negation P and negation Q or R. Negation P or negation Q or R. Okay, so this is going to be equivalent to this. This we are not touching the first term. Or what happens to our second term? We have to come to slide number 8. In slide number 8, the second term is going to be just negation P or what is this? Negation Q or R. This was our last term in slide number 8. So look at these two things. Whatever is available inside is available here also. That means what? One is the negation of the other. So it is of the form negation A or, but what do you know about negation A or A? Negation A or A is equivalent to tautology. Therefore, this is equivalent to tautology. Hence, what will I say? I will go back to slide number 1. So, I will go back to slide number 1. What I have to show in this slide? I have to show that it is a tautology. Having gone to show that it is a tautology, see what have I done here? I have to proceed. I have come to slide number 9. And at the bottom, what have we shown? We are having negation P or P, the final slide. Therefore, what have we shown? We have shown that it is a tautology and hence our proof is over. So now let us clean through. So this is our last slide. Okay. So I think I have brought the first slide down, but this is our last slide, whereby this particular slide has to go. Let's reset again. So we will have a slide validity. Then we check validity for one more problem. Then we check the validity of truth table, what is meant by the validity, and then we check validity for one more problem. Then We check one more validity for a problem, and then we check validity whereby we showed that the arguments are valid. Then again we found out one problem. Where did we go for that? We went down. It is a valid argument, and so on. As we scroll, we also did a problem where it is not a valid argument, and then finally we have done a huge sum whereby we were able to establish implication using the laws of logic. So that's what we have covered for the entire session of today. So we have this, and where is our next slide? So that's how it goes. My recording is